Welcome to our weekly podcast on looking at climate change, sort of going green. And today we're going to have a look at, in podcast 4, messy methane. So methane, well, what do you know about methane? Well, I can tell you it burns well.
Yeah, we use it for gas and things.
It stores quite well.
Well, sort of.
Yeah, well, no, you can compress it, and it's like a lot of the alkanes. They can sort of be compressed. And I've watched the ferries go into the Isle of Man carrying sort of liquefied natural gas. So it's quite good stuff, but it's got a bad name.
Well, it's got a bad name for, unfortunately, what methane does do, and is what is known as, is a greenhouse gas.
So
in that, what happens is it basically traps heat and re-radiates it out.
And methane, we know, it's emitted when you produce, I don't know, and transport, I suppose, coal, natural gas and oil. Methane is also famous for coming from livestock, especially of the cattle variety. But also, I suppose, it's also available largely in sort of waste landfill sites. They're quite well known for their amount of methane.
The critical thing about the methane generation is that anaerobic respiration, as in a respiration without the presence of oxygen. So we're talking, say, in a compost heap, that does produce the methane there. So, so obviously composting, which is seen as a good thing, but if you don't aerate it, turns suddenly the good, nice thing into this, problem.
Yeah. And you said it's a greenhouse gas, but it's not just really just a greenhouse gas, and people think about carbon dioxide as a greenhouse gas, but methane's 25 times as sort of potent.
I don't know if it's like 25 times, but it could be something like 20. But yes,
it's that order, isn't it?
Yeah, it's quite a lot. So for one molecule of methane, it's the effect of having 20 or 25 molecules of CO2 in that. That's how effective it is at, I wouldn't say reflecting the heat, but it's
keeping it, really.
Yeah,
it pulls in the heat.
Radiates the heat out.
There is some good news, I suppose, that research shows that the methane in the upper atmosphere lasts on average for about 9 years, whereas carbon dioxide stays up there for, 100 years. I find any time people are talking more than probably about 10 years, it probably means they haven't measured it properly. They've only trying to extrapolate and hope they're right.
Yeah. So, but you've got to understand that although methane's bad, it is good, as in it is natural gas. It is a very good fuel source in that regard, as in it doesn't use up, the vast quantity, say, like petrol, which is an 8-chain alkane.
You get a lot more power out of it.
More power than out of it, which is good. You see, that's why we use it for natural gas.
Bang for your buck, as they say. However, I noticed that on my car, unlike my cooker, on my car I have to have a catalytic converter fitted. I don't have a catalytic converter on my cooker, which would suggest that when my cooker burns, and I do burn on methane, that the gas is turned, basically, when it's burned, into oxygen. The carbon dioxide burns with oxygen just to produce carbon dioxide.
We'll get there. You'll get there.
Water. Whereas octane, petrol, burns to produce carbon dioxide, water, and then also nitrogen oxides.
Well, you're actually not in petrol, obviously, you're not burning, because instead of burning pure oxygen, you're burning air, which is different. That's the critical point there.
But when I'm burning them with my cooker, I am just burning air there. Why does my cooker not produce?
Well, the answer is, unfortunately, it's called the internal part of the combustion, because of course a cooker is external combustion. So when your cooker burns, for any fire that's outside, only the oxygen burns in that regard, whereas the nitrogen, although gets really hot and excited, doesn't actually take place.
Is that because you're not compressing it?
It is when you compress it, as you compress air, you compress everything inside, which gives it energy in itself. And then when you ignite trying to burn the oxygen in that compressed air, suddenly that compressed nitrogen, which had a good buck sandy, suddenly then basically not explodes. That's the wrong way to put it, because you're exploding is the fuel that's going bang. But in that heat and the pressure, it basically unbonds itself with
Itself and
makes all these nitrogen oxides, which is what the catalytic converters are trying to stop.
And it's not one nitrogen oxide, is it? It's dinitron tetroxide
it's
and variety
like
of different things.
6 different types. Yeah, it's a problem. As I said, that's why open air or external combustion doesn't have the problem.
Plenty more oxygen.
Because there's plenty more oxygen, but at the same time, it's the energy requirements for nitrogen to undergo all these things.
So we're also looking at, with methane, other problems with methane, trying to put it out. So we've got this talk from the government at the moment about, well, you may have to sort of stop eating beef and start eating sort of more cereal, because these cows are producing too much methane.
Yeah, but unfortunately, it's part of the digestion. Any herbivore, their stomachs it's because there's an enzyme. They're breaking down complex molecules of sugar. Not necessarily glucose, but all those sorts of things. And unfortunately, they don't convert those sugars well, or they don't break them all down efficiently.
Well, actually, they don't. All these animals actually don't do anything themselves anyway. They all use the same bacteria.
They all use, and so whatever's left, or usually, which is methane, is then belched out. Either from the backside or the front. Both sides are open,
Yeah, and out comes methane.
And out comes methane, so it's a problem in that regard.
I was talking to one of my students a few years ago, and he was on holiday in America, and he said they drove through the great state of Texas, and he said what he noticed was a straight road, and all he saw next to the road, both sides, were cattle. Mile upon mile upon mile. We don't get that in this country, but
not to the extent. It's one of those things where, how much cattle, or how much does agriculture in sort of livestock is required? And, you take the resources. They use probably like 4 times as much water. Twice as much land. And all these things.
It's probably even more than twice as much land. Yeah.
But then it takes. How long does it take for a prime, steak to actually? How long do you keep the animal alive? That's the wrong way to put it. But when do you butcher the animal for your steak? At what age? I know. For lamb, they do 8 weeks or something. They either do a new leg of lamb, or of course. Because of course they use sheep for the wool, and you see, and that's where, Yeah,
technically, if you have that's not lamb, the sheep, the people still call it lamb, but it's actually mutton.
Mutton, yeah, I know.
And
so
trying to buy a leg of mutton is actually much more difficult than you imagine.
Well, yeah,
you don't see it in the supermarket.
You don't, because one of the critical things is they're keeping the sheep alive for the wool, which is, and that's the whole thing. But cows, all right. What can you get from cows? It's the same argument with pig. What do pigs or cows produce?
Well, you've got the meat, but you can also get the other things like the leather.
Yeah,
the
but
skin.
how much leather do we use now?
A lot less.
You're talking leather is very much used, in regard. But wool, you see, it's hair. It comes off. You don't not harming the animal, so therefore
No.
it's actually seen as better than going that way. Whereas leather, you're that's the skin of the animal. So,
But much is used nowadays still plastic, unfortunately.
but it's plastic, because it's replacement of those things. So, you've got to look at sort of, yes, it's a fault, but what does the cow bring us or give us? And the answer is, unfortunately, it brings us just the meat.
Yeah. Well, let's talk about methane more. What is methane? Now, I've got a model of some methane here, and all it consists of are basically some molecules of hydrogen and
It's 4 molecules of hydrogen and
four atoms
four
of hydrogen
atoms.
and 1 atom of carbon. And these hydrogens are bonded covalently to this atom of carbon. And when this is burnt, then the hydrogen is removed, and that reacts with oxygen to make H2O, water, and the carbon reacts with the oxygen to form, in theory, carbon dioxide. But I do know that we sometimes get carbon monoxide, which people try not to talk about too much, especially at lower academic levels, because they don't like trying to draw out what it is, because the students get really confused. And we've also get sometimes quite a lot of soot, carbon particulates.
Just carbon, just on its own, carbon, yeah.
I did an experiment this week, and in this experiment we simply had a candle. We were making a little fire extinguisher to put it out, but it was noticeable how much black soot was coming off of the flame.
Well, this is where technically, a candle in regards to that doesn't burn well or doesn't burn effectively. That's more the
Doesn't burn hot enough, is it?
No, it doesn't burn hot enough.
Think of the Bunsen burner. You have your yellow safety flame where you're not letting enough oxygen get in and mix with the methane to make it sort of burn hot enough. And that's our yellow safety flame. I always laugh about this idea of having a yellow safety flame, producing carbon monoxide and carbon particulates.
Well, the answer is the reason it's called the safety flame is because it's visible.
Yeah. As opposed to the invisible, really hot flame, which is much more efficient.
Yeah, so
producing just water and
that's the
carbon dioxide.
So in that regard, you're talking about the efficiency of burning, and it has to be done at a high temperature. It has to be done in a presence of lots of oxygen for it to work effectively.
So this carbon dioxide that we're producing, of course, is a greenhouse gas, and what we're starting off with, the methane, is an even more potentially dangerous.
So what? So let's take a fundamental thing. If I take all the methane in the atmosphere and I burn that, produce the CO2, surely that's a net gain in regards to, yes, the amount of CO2 is increased, but I've decreased the methane, which of course is 10 times worse. So if
let's say 20, 25 times worse.
20 times, effectively, surely that's a net gain in regards to climate emissions, even though I'm increasing the amount of carbon dioxide, which is quite a bad thing to looking at it, because surely, if you use both, it's even better. But it is that how bad or how worse methane is. But how do you get rid of methane from the atmosphere?
Well, I know it does disappear. As I said, it disappears in about sort of 9 years or so. But no, I've got no idea. How would you actually try and remove the methane naturally? from the atmosphere?
Well, this is where natural methane. Funny enough, it actually, bizarrely, just escapes.
What, straight into space?
It just straight out basically into space. Although it's not quite there because it rises up because of being gas, but it's not light enough to technically. So it actually goes the tippy toppiest out of the atmosphere.
I did wonder whether we might have the UV rays
That breaks it down. Yeah,
breaking it down, making it into a radical, and that's where we lose one of the hydrogens.
Yep.
And you get this very reactive species that will now go and react with perhaps even the oxygen in the ozone, and that'll also break down the ozone layer. So that's
I mean, that
not
could
looking
be
quite so good.
That could be a mechanism. It's one of those things where that's probably happening.
So we've got lots of natural sources of methane in the atmosphere. Some of that really is just going to come across, as you said, with anaerobic respiration from generally certain animals, a lot more than others, like cattle. They are particularly bad. You said that all animals, including man, produce methane.
Well, I didn't actually. It was all herbivores.
All herbivores. So you're not telling me for a moment then that perhaps a vegetarian or vegan could be worse?
Technically, yes, but at the same time, no, because they don't actually have the enzyme which the cattle do. If they took enzyme, as one of these supplements, then yes.
Now, I know that a lot of the methane also comes from wetlands. The thing that we try to promote are bog lands, and about 20% of all the atmospheric methane does come from these wetlands. We've got this idea that you've got the sinking action of the soil. From what you said, anaerobic methane production, and this is the sort of stuff that you see in the films, the sort of the bubbles coming out of this sort of the swamp.
Yeah, exactly. When they bubble.
So we've got the ruminants, the herbivores, if you prefer. They're going to produce quite a lot of this sort of methane by breaking down the plant materials that they're eating. How about, though, living plants? Are they responsible, do you think, for any production of methane?
Oh, I reckon a little bit.
It's up to about 30%.
Oh, quite.
It's really quite high where it comes from. So we've got quite a lot coming from sort of just ordinary plants sort of existing. But there are some other places that we get carbon dioxide, and you may hit methane. And one of those is the famous permafrost. Methane that gets frozen in permafrost, that's land that's going to be frozen for years and years. When it's slowly released from the bogs, the permafrost, it melts, and with rising, of course, global temperatures, we're seeing more of this happening in places like Alaska and Siberia. And we've got, when they last did the research in Siberia, which I know was 2006, they were showing that we're getting 5 times the amount that they thought they were going to be getting. So that's quite a worry about how much methane is coming because of the extra heat of global warming.
Terrible, isn't it?
Yeah. Then I suppose if you've got all these eco-warriors doing their bit, they're trying to do their bit on ecological conversion, trying to sort of rescue lands and convert it back. Well, I suppose they're going to sort of make it worse. I was watching an article on trying to sort of put the peatlands back into Wales.
Oh, yeah.
And the idea of doing that, it will hold the water, and it's going to hold the water back to save the Severn, so the towns down the Severn aren't going to get some flooded. But if we make more peatlands up in somewhere like Wales, then of course we've got a problem, because we're actually making more methane with the sort of methanogenesis of plants and wetlands.
Yeah, well, it's one of those things where I think it's we've disturbed the natural cycle in regards to everything. That's we're releasing a lot more methane suddenly than everything can handle.
Yeah, and we've got lots of farms, and of course farms aren't really helping. They're natural animals, but when you try and do all the farmlands, then we're actually producing even more.
It's sort of like, it's 24 times the amount of animals that should exist effectively, and that's just to cope to feed the population.
There's another one. There's one plant. I don't know if you know one plant that seems to produce more methane than any other. It's a crop. I'll give you a hint.
Corn?
No, rice. Because it grows in the famous paddy fields, which are all wet boglands.
Yeah.
And
I can
so
see that, yeah.
rice agriculture sort of yields quite a lot of metric tons of methane into the atmosphere every year. And if you can sort of compare the amount of methane now with perhaps 5,000 years ago, when the paddy fields were sort of created, we're finding that the amount of methane has increased dramatically.
Well, there you go. So, rice off the menu,
Yeah.
Almost as well as beef.
But unfortunately, as well as taking beef off the menu and rice off the menu, you're going to have to take waste off the menu as well. Because I said landfill, that's accounting for nearly 20% of the global methane emissions.
Well, that's where people are throwing, say, food away.
Yep.
And it's going to landfill rather than through composting, or even actually burning it. That's the wrong way to put it. But it's going through the wrong place.
But even if it goes through the right place, and you sort of have to accept that we're going to have things like wastewater treatments. The wastewater treatments, of course, have got all these bacteria in there living on the poop, and they're having a lovely time. And of course, they produce their fair amount of methane as well. So that's not.
I'm
good.
sensing this is just a lost cause in regards to. Everything, you're damned if you do and damned if you don't. You try to be good and recycle.
Well, I think this is one of the problems that we have when we look at sort of this idea of going green. People talk about, let's get rid of this. But they don't take into account that if they get rid of this, then people have to perhaps eat something else, and that might produce just as much. If you get rid of, let's say, all the cars, and take them all from petrol and you put them all onto electric, you've still got to make your electricity somehow. And at the moment, still a fair amount of that stuff in this country is still made by methane. So we're not necessarily improving things. How about powering your car by methane, though? And then we could burn all that up.
Well, I know you've got all these LPGs.
Yep. And they're supposed to be a lot better. However, there's a fair bit of unburnt methane that gets out. It's called methane slip. And it's about 7 grams for every kilogram of liquid natural gas.
Well, I think then we need to, LPG needs to stop methane slipping. It needs to be better.
The reason is, of course, the molecules are very small and they can actually seep out very slowly through
pipes,
metal containers. Everyone seems to think you've got a gas cylinder and it's full up and it's safe. But it isn't. It leaks.
Well, it's like if people think rubber hose, it contains water, no problem, but it only contains water because water's it's the right size not to fit through. But as I say, methane. I wouldn't say it's smaller than water, but I would say water's got a funny shape, whereas methane's very symmetrical in that regard.
Water's a very odd substance, whereas methane is much more sort of...
I wouldn't say normal, but it's less exciting in regards.
Yeah. So, how can we get rid of all this methane? We talked about radicals as one way of doing this, of trying to sort of get this methane. And if I react it with some water, so we get UV, we get our methane, it reacts with water, and then we can get methanol.
Yeah.
That could be one way of trying to do something. I know that one of the problems that we get is with this meeting ozone, and it tends to destroy the ozone. So that's not very good. So what else can we try and do with this?
Well, the problem is it's such a simple thing. It needs even if you're making it for alcohol, which is ethanol, you need to take 2 parts. You need 2 of them, 2 of these methanes, before you even get started. But on that regard, it is the simplest of the alkenes, and all alkenes can be built from methane.
Well, there is something that we call methanogenesis, which is taking the methane and giving it to some bacteria, and then they exist in the earth's soils all over the place, and they tend to sort of take this methane and turn it into, unfortunately, carbon dioxide. As we've said, it's 25 times or so less.
And then we just have to get rid of the carbon dioxide. As I said, problem solved. It's easy, And just fortunately, the bacteria, they need to get on with it. They're not big enough. There's not big enough. That's the wrong way to describe it. It's not as much of them. We need more of them.
Well, I know that scientists have looked at the sort of natural methane cycles, and they've seen that there are seasonal changes in the amount of methane. Temperature during the day can affect the amount of methane that's sort of given off, and I'm not necessarily talking from animals here, but from anywhere. So we can see those, and if you go back and have a look at this methane production through the ages, ice cores are one way they actually do this. We can see that up until sort of the Industrial Revolution, methane wasn't too bad. But then, once it started in, let's give a date, let's say 1700s, for the start of this methane production as a byproduct, we were getting about 1% per year increase until about 1990. And then there's some good news. From 1990 to the current date, we're not seeing an increase in the amount of methane production.
Okay.
It's more or less stable.
Okay.
Which is looking, hopefully, quite good. But we've got to do something about what there is up there. And we know, of course, it's going to disappear over 10 years. And, of course, that's a half-life type of thing. So it's going to go down gradually. So we are doing the right sort of things somewhere along the line. But we perhaps need to try and get still more out, because if you're not putting methane out and you're controlling the methane more, unfortunately you're making more carbon dioxide, which is still a greenhouse gas.
This is the big thing. It's the worst ever. It's devil's advocate sort of.
Yeah. So there we are. There's our discussion on methane and how good and how bad it is.
Mm-hmm.
We'll see you next week, when we'll do our 5th podcast on going green. Thank you for watching and listening.
Bye.
Bye-bye.